Welcome everyone, you're watching Math Guys, and in this video edition we are going to talk about some of the important and the commonly used trigonometric function that you would come across either in high school or the college level math. Now there are 6 main trigonometric functions that you would have to know, which I have it in the board here. The first one is sine, we have cosine, tangent, cosecant, secant, and the cotangent. Now let's see how we could define these 6 functions based on a right triangle. Now for that I would have to make a right triangle here. Let's see if we could make a right triangle. Let's have a right triangle. Okay, and I'll name this angle theta as our reference angle. We'll take this angle theta as a reference for naming the remaining 3 sides of this right triangle. So the side that is opposite to this reference angle is called the opposite. In short, I'm going to write it as OPP. The side that is adjacent to this reference angle is called the adjacent. In short, I'm going to write it as ADJ. And the longest side in a triangle is our hypotenuse. In short, HYP. Now, let's see how we could define our trigonometric function based on this right triangle. So our first angle, which was sine theta, would be equal to the opposite over the hypotenuse. Next one was the cosine. So cosine of our reference angle theta would be equal to the adjacent. Sorry here. So cosine is equal to the adjacent and over the hypotenuse. Tangent would be equal to the opposite over the adjacent. Likewise, the cosecant is equal to the opposite of sine. Now, cosecant and sine are opposite, so basically opposite of sine, which would give me hypotenuse over the opposite. Likewise, secant is opposite of cosine, so I can write this as the hypotenuse over the adjacent. And cotangent is the opposite of tangent, so it is adjacent over the opposite. So based on this, we could define the reciprocal functions, which basically the sine of any angle x is basically a reciprocal of cosecant of x. Sine and cosecant are the reciprocal functions of each other. Likewise, we have cosine is the reciprocal of the secant x. Tangent is the reciprocal of the cotangent x. Cosecant, like we just said, is the reciprocal of sine. Secant is the reciprocal of the cosine, and the cotangent is the reciprocal of the tangent of x. And this is our reciprocal functions. Apart from this, tangent and the cotangent have some other way to now there are other ways in which we can represent the tangent and the cotangent functions. So see, the tangent functions, any tangent of any angle x, is equal to sine of x over the cosine of x, and the cotangent of x is equal to the cosine of x over the sine of x. Now why is this the case? Let's see. So we have tangent x, which is said is equal to the sine of x over the cosine of x. Now, if we remember from our right triangle, sine of x was the opposite over the hypotenuse. Likewise, the cosecant was adjacent over the hypotenuse. Now, bringing the bottom fraction to the top, I get opposite over hypotenuse times, when I bring the fraction up, I have to multiply it by the reciprocal. So hypotenuse cancelled gives me opposite over the adjacent, which from the right triangle that we just saw a moment ago is equal to the tangent of x. So this identity works. Now similarly, we can do the similar things with the cotangent now. We said it is equal to the cosine of x over the sine of x. Yeah. Again, from the right triangle, we can say this is adjacent over the hypotenuse, and the sine x is the opposite over the hypotenuse. Again, I'll bring this up. Adjacent over the hypotenuse times the hypotenuse over the opposite, multiplying by the reciprocal. Hypotenuse is gone. Adjacent over the opposite, which from our right triangle we know is the cotangent of x. Alright? Now let's look at the Pythagorean identities when it comes to the trigonometric functions. There are some of the Pythagorean. So Pythagorean identities. I'm sorry, this is identities. Let me clear this up for you. Okay, so let's see. So we have the three main functions that we would have to remember here. First one is sine square any angle x plus cosine square of any angle x is equal to 1. Now from this we could derive a couple different identities. I can solve for sine x here. I can subtract the cosine on both sides to get minus. So I could solve for sine here. Sine square x then becomes 1 minus cosine square x. Similarly, if I solve for cosine, doing the same way, I get my cosine square x equals 1 minus the sine square x. So this is my first trigonometric identities, but in the Pythagorean form. All right. Now let's look at the other one. The second one, which we want to remember, is the secant square x minus the tangent square x is equal to 1. Now similarly, just like we did for the sine and cosine function, let's solve for the tangent here now, or the secant first of all, I'm sorry. You can add tangent on both sides to get secant square x equals 1 plus the tangent square x. And similarly, I can get my tangent square x equals secant square x minus 1. So there's a couple important things we could get out of this. And this is my second one. Now let's look at the last one we have to remember. Cosecant square x minus the cotangent square x is also equal to 1. Now, I would solve for, again, I've tried to solve for both of these here. I would solve for the cosecant now. gives me cosecant square x equals 1 plus the cotangent square x. Similarly, cotangent square x becomes cosecant square x minus 1. So we got a couple different important identities that we use a lot when we solve problems in trigonometry. Now, let's change the topic a little and let's look at some of the other commonly used trigonometric functions. Now, the main one that I'm going to talk about here is the double angle. We use this a lot. The first one is the sine double angle, sine 2x, which is equal to 2 of sine of x cosine of x. Right? The second one is the cosine of double angle, which is equal to cosine square x minus the sine square x. Now I could plug in for sine square, which we just did a moment ago. For sine square, we can plug in, so cosine square x, I'm sorry here, let's see, minus, now for sine square I could plug in 1 minus cosine square x, the one that we got from the Pythagoras Identities. Now this becomes cosine square x minus 1 minus plus cosine square x gives me 2 cosine square x minus 1. Cosine square x plus cosine square x gives me 2 cosine square x minus 1. So this is, you can either remember this form or that form, or instead of replacing sine, if I replace cosine here, I would get 1 minus 2 sine square x. So you can remember either this form, or this form for the cosine of 2x. Now let's look at the third one, which is the tangent double angle, equals 2 tangent x over 1 minus tangent square x. So this is the tangent double angle. Okay, now the next thing we're going to move on is something called power reducing formulas. Right, there are some of the formulas which help us reduce the power. Now, which means basically, if we have a cosine square x, how can I get to cosine of x, or the double angle? We could go to double angle. So basically, I just reduce the degree of this function from 2 to 1. Let's see, and we have some formulas that would help us do this. The first one we're going to talk about is for the sine square x, and we would use, this is 1 minus cosine of 2x over 2. Now how do we get this? Now we just saw, we can do the proof here. Like moments ago we just saw the cosine of 2x, one of the form was 1 minus 2 sine square x. Now let's solve for sine square here. I would do plus 2 sine square plus 2 sine square x. This becomes cosine of 2x plus 2 sine square x equals 1. Now we'll subtract cosine of 2x on both sides. Let's bring over here. We get cosine of 2. I'm sorry, this would be the sine. we have 2 sine squared x equals 1 minus cosine 2x. Divide both sides by 2. Gives me sine squared x equals 1 minus cosine of double angle over 2. So I just reduced my degree, so power from 2 to a 1. So then this is equal to what we have here. Now similarly, we can do other one for cosine squared x, which is equal to 1 plus cosine 2x over 2, and we could prove it similarly, just like we proved the sine squared function. And also we have 1 for the tangent x here, which gives me 1 minus cosine 2x over 1 plus cosine 2x. Okay, and these are my power reducing formulas. This in combination with the one with the sine square are the power reducing formula. Now these are okay. Now so we talked about let's do a recap here. The first thing we talked about was definition based on the right triangle definitions. Next thing we talked about was the Pythagorean identities. And we talk about double angles. And we talk about the power reducing. Now these are the most commonly used trigonometric identities in the high school and college. Now there are many others which I didn't go over in here. Now if you want me to go over any of those, you can request us a video, and we will make a video just for that. But apart from that, this is all we have for now. Thank you for watching, Math Guys. We'll see you again. Thank you so much.